This is Josh White with JW Math Tutoring. Today's video is going to look at 10 problems from the December 2024 Digital SAT Math section. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Before I begin going through these 10 problems from the December 2024 Digital SAT Math Test, I just want to highlight a couple things that I mention in each of these videos. So first, these questions are all self-reported. So in some of them, I've had to basically, just kind of like make them numbers in order to make the questions work out properly. And also related to that, you'll see a lot of them are done as free response questions, but on the actual exam, they could be multiple choice. And so if they are multiple choice questions, then you might have other methods available to solve the problem that you don't have when it's a free response like I'm solving it here. So just keep that in mind. I'm basically, again, I'm going off what students who took the December 2024 test have reported. Besides that, if you like this video, obviously please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Be sure to check out the videos I have covering problems from the other months as well: November, October, August. What else do we have? June, May, and I think that's pretty much about it. So with that being said, let's go ahead and get started here with question number 1. So here you have this quadratic equation with a bunch of constants in it, r and s, and also you have this constant k in the problem. So we want to know the smallest possible value of k where this question has at least basically 2 real solutions. So the traditional way that you would solve this is you would basically set up the discriminant, set it greater than or equal to 0, and then when you go ahead and rearrange that, you're going to find that you will have r over s on one side of it. So what I mean by that is, we have b squared minus 4ac. That's the discriminant. For real solutions, we want it. I guess for 2 real solutions, technically we want it to be simply strictly greater than 0, not equal to 0. So now if you plug in the numbers, you're going to have negative 24s for b, and then minus 4 times 6r times 6r for c. Okay, and then we simplify this out, we get 576s squared. And then for the next part, this just becomes minus 144r squared. If you go ahead and separate these, you get 576s squared greater than 144r squared. And then what you're going to do is you're going to divide both sides by 144. Okay, so if you do that, 576 divided by 144 is just going to reduce to 4 over 1. Then you're also going to divide both sides by s squared. So what you get is 4 is less than r squared over s squared. Or if you want to rearrange it, you could also say r squared over s squared less than, excuse me. This is going the wrong way. Sorry, it's this. It's 4, 4 is greater than r squared over s squared. And then if you rearrange it, it becomes r squared over s squared less than 4. Next, you would take the square root of both sides. And so technically, when you have an inequality, essentially a quadratic inequality, that's what we have here. So when you square root on the left side, okay, that just becomes r over s. Now on the right side, okay, the square root of 4 is obviously 2, but the way you actually solve this is technically 2 is your critical point. Sorry, positive 2 and negative 2, because when you take the square root, you have both plus and minus. And then what you need to do is essentially you set your critical points up on a number line, and then you go and you see like in what regions on the number line does the value exist in to make the inequality true. So what we mean by that is for r squared over s squared, okay, to be less than 4, essentially, if you take, so again, we're looking at like r over s, the whole thing as our number, right? if you say that R over S is equal to, so like this is our critical point, this is our critical point where it's equal to 0. So let's say you take like -3, here we could just put a 0, here we could put +3, right? So if you put -3 in for R over S, and then you square that, so you put it back into the original inequality here, right? -3 squared becomes 9. So is 4 greater than 9? And the answer is no, it is not. So therefore, this region is not where the solution lies. And the same thing is going to be true in the region greater than 2. So in other words, if you let R over S be +3, okay? So it's like 4 greater than, R squared over S squared, which is, you could just rewrite as R over S quantity squared. So when you square that, you get, again, 4 is greater than 9. That is false. That is not true. So the solution is not out here. The solution is going to be solely this region in here. In other words, all the values between -2 and +2 are for the fraction R over S that make this make this equation have two real solutions. So the question is, what's the smallest value? Or in other words, what's really K is, think of it as K is the lower limit, or K is the floor for how low your R over S value can go. It can't equal it, it still has to be greater than it, but it's going to be right here, -2. -2 is the floor. -2 is the bottom number in the interval such that if you plug it in, you would still have any number over -2, which is also less than +2, would give you two real solutions. Okay, so the smallest possible value for K of this is going to be -2. All right, and that's basically the final answer. Now, if that was too much work or you're too confused by it, that's fine. I will show you how to do this basically in Desmos. So what I'm going to do is just drop this down. Let me scroll down a little bit here. Okay, problem's still on the screen. First, I'm just going to type this whole thing in, except there are a couple changes we have to make. I am going to replace R with P. The reason I do that is because in Desmos, R is defined to be the radius of a circle. So we can't technically use R. If we try to use R, it'll mess up essentially the problem. It won't work out properly. So every R I replace with a P. Oh, I'm also going to get rid of the equal 0 because I really want to graph this thing and look for the solutions as x-intercept values. All right, so we've got P, we've got S here. And essentially our K value is P over S, or R over S, right? So now what we can do is basically, oh, actually, sorry, one thing that we do need to notice, which is that R is positive and S is negative. Right here, R is greater than 0, S is less than 0. So when we go to do this in the problem, we have to make this a negative number. All right. So if you just let t be constant, or actually, let's do it like this. Let's let s be -1. Okay. And now I'm going to move the p, which is equivalent to r, and I'm going to see essentially like what's my smallest value of k, which will still give me two real solutions. So notice as I'm increasing this, as I'm making p, i.e. r, larger, notice that that is technically making k smaller, right? It's going to -1.8, -1.9, blah, blah. Okay, and notice right here at -2, excuse me, it has one real solution. So that means, like, again, -2 is the floor. -2 is the lower limit for k. So in other words, your k value has to be greater than -2. Notice if I go this way, if I make it less than -2, it just keeps going up and up and up and up. There's no real solutions. So I have to go the other direction. Okay, right here, I am technically at a k value which is greater or r over s or p over s, but again, think of it as r over s value, which is greater than negative uh, negative 2, negative 1.9. And notice here there are two solutions, two real solutions, which is what we want. Okay. And you could try moving this in like various directions. I mean, you can see, I mean, basically you can go down to like, 0.00001 or whatever, because R has to stay positive. But the reason that you know that the K value will be negative 2 exactly, okay, and not some other number, is because notice right here when I set R or P equal to 2 and S equal to negative 1, the K value is negative 2, and that's exactly one real solution because it just touches the x-axis. So that's how you know that this is the floor, this is the lower bound, and therefore this is the answer. Because anything, like even if you make this, 1.999, like you can still technically zoom in here, you know what I mean, and see that there are two real solutions. The vertex is still below the x-axis. So the reason that the reason you know it's 2 for the correct answer for k, which is here, it's just the ratio of p over s or r over s, is because, or sorry, not 2, negative 2. The reason you know it's negative 2 is because at that point, when k is equal to negative 2, you have exactly one real solution on the graph, okay? So anything above that will give you two real solutions. All right, sorry, took a little while going through that one, but I just want to make sure that you understood the Desmos solution in addition to the solving by hand method. So for this one, again, I'm going to do this two ways. First, I'll show you how to do it by hand, and then after that, I will show you how to solve it using Desmos. So what I would do is I would recognize on the left side here, I can rewrite this as n to the 2/3 power. On the right side, this is k to the 2/5 power, just going from radical form to rational exponent form. Now, you can technically replace k with what it's equal to, which is just n to the 2a plus 1. So I'm just going to do that. So I have n to the 2a plus 1, and that whole thing is raised still to the 2/5 power. So because we're raising to a power here, we can just multiply the exponents. So really what we have is, for this whole new exponent here, the 2 is on top, just like the 2a plus 1. So it's really 4a plus 2, over 5. That's the full exponent of the n. And that's equal to n to the 2/3. Okay, so now you can just set the exponents equal. 2/3 equals 4a plus 2 over 5. You can solve this by hand if you want, cross multiply and get 10 equals 12a plus 6. And just go ahead and subtract. And you get a equals 1/3. Now, you could also use regression to solve this. If you set up basically, excuse me, the equation here in Desmos. All right, so what we would do is I would just start off, and you can write it in rational exponent form, but we should be able to. Actually, I'm just going to do it, in rational exponent form because it'll just be so much quicker than having to go to the function menu and looking up like the cube root and the fifth root and type those all in. So I'm just going to take the left side. I'm going to put x instead of n. And on the right side, I'm going to replace k. That's what it's equal to. Again, I'm using x instead of n. Okay, so I've got that to the 2x plus 1, and then that whole thing is going to be raised to the 2/5 power. Now, this does not give us the right answer because I have not defined x1 as a list. So what I need to do now is define x1 with at least two values here. Now you can see it returns for a the correct value of 0.33333, which which is the equivalent of 1/3. Okay, so correct answer, you could enter it in as 1/3. You could also enter it in as 0.333, or you could enter it in as 0.3333. Either of those three choices would be acceptable. All right, moving on to the next question, number 3. Here you have a situation where they describe about a family renting movies for a week, and the 36 in this function represents their total budget, basically total amount of money they have, and they want to know which expression represents the amount of money that they spend every time the family rents a movie. So the answer to this, is just going to be B. It's 4, because what's happening is they're starting at $36, right? And then they're subtracting from that 4 times M. Well, M is just the number of movies. So notice that's multiplied by 4. So that's what tells us that the cost per movie is $4, because $4 per movie times M movies gives us a total dollar amount that we subtract from 36 to get the amount of money left. So the answer to this is just B, 4. All right, next up, question number 4. Here we have a circle. It is not, notice it's not in standard form as it's given. But basically what we want to do is find the value of A such that the circumference of the circle is equal to this expression here. So first I'll show you how to do this by hand, then I'll show you how to do it in Desmos. So if you're going to do this by hand, what you would first do is start to complete the square. Move the negative 39 over to the right. And remember, we take 12 divided by 2, the B value, and that's 6, and we square it. And that goes up here, and that also goes on the right. And then the same thing here, negative 18 divided by 2 is negative 9. That squared is 81. That's what fills in the blank on the left and the right. All right, so if you go ahead and do this, on the right side, you get 156. We don't have to actually finish completing the square on the left because we don't care what the center is. So that means the radius of the circle is square root 156. If you go ahead and simplify the square root, it's going to be 12 and 13, and then 12 is 4 and 3. 4 is just 2 and 2. So this becomes, you have a 2 outside, and then inside you have a 13 and a 3, which is 39. That means the radius, that is the radius, sorry, the circumference is equal to 2 pi times that, which is 2 pi times 2 root 39, which is equal to 4 pi root 39. So if this is equal to 4 pi root A, well, the 4 pi's cancel out, so A has to be 39. So correct answer for this is just the number 39. Now here's how you could solve this using Desmos. So let's go back here. Let's first type in the circle equation. Okay. Zoom out here. All right, we need to identify the radius value of the circle. So I'm going to look for the max and min points, which are right here. I'm going to do the distance formula between them. Okay, so again, they're both going to be -6, and it's 21.49, -3.49. All right, this is technically now the value of a diameter. So what I need to do is I need to divide the whole thing by 2 to get the value of the radius. All right, let's try not to delete this now. So divided by 2, that's my radius, and I'm going to define that as equal to capital R. Notice you can use capital R here, but you cannot use lowercase r. Lowercase r is something that's already defined in Desmos. Okay, so next I'm going to do this. Say the circumference of the circle is equal to 2 pi times r. So that is the circumference of the circle. Now, I also know that that value is equal to 4 pi square root A. So I just set up a basic little regression statement here, and I said, okay, take this exact value right here. Because I'm defining R and C using these capital letters, that carries along the exact value. So there's no rounding or no issues with that. So you get exactly 39. And I do a regression on equal to 4 pi times square root a, and it solves for a, it gives me 39. So this is how you could do the entire problem in Desmos. All right, next up, this is a repeat question. However, I'm going to show I believe, a new method to solve this because I have not done it. I don't think I did it this way in the previous video where I solved it. So you have a tree that grows some number of centimeters every m months. Just this number changes, so obviously the answers all change. And they want to know what is the expression that represents the growth after k years. Here is, I think, the easiest way to figure this type of problem out. You know you're starting with 117 centimeters per m months. All right. Now, we're going to just do unit conversion. Basically, this is factor label. So I'm going to do, and I'm going to get, and I want the final answer to be number of centimeters per, or per k years, or not per k years, but number of centimeters for k years. I'll show you what I mean. So, okay. I'm going to first convert months to years. So I know that there's 12 months in 1 year. So if it grows 117 centimeters in m months, it would grow just whatever 117 times 12 is in m, basically in that number of years. And then what I'm going to do is I'm going to multiply by k years. And now see, years cancel out. And now what I am left with is the expression showing me the total growth that for this tree after k years. And it's basically going to be 117 times 12, k on top, m on the bottom. 117 times 12 is just going to be 1404. So this problem, the answer to this problem is just going to be letter C right here. Now, here's an alternate strategy you could use. Basically, this involves picking numbers. So what I'm going to do is I am going to let m equal 6. So 117 centimeters every 6 months. And then I'm going to let k equal 2. So in other words, if it grows 117 centimeters every 6 months, how much will it have grown after 2 years? So that's just going to be like 117 plus 117. That's like, this is year 1, and then 117 twice again. Basically, this is year 1, this is year 2. So after 2 years, I would expect this tree to have grown, you can just add these all up, 468 centimeters. Let's just confirm that. Yep, 468 centimeters. Okay. So now, basically I'm just going through the answer choices, and again, I let m equal 6 and I let k equal 2. I'm just going to type them in, and I'm going to see, does this equal 468? The total growth I would expect for 2 years. Okay, so answer choice A, no. All right, let's switch the M and the K. Nope. All right, let's move on to C, 1404. This answer choice C has K on top, M on the bottom. Okay, this equals 468. That confirms it's the right answer, but you can also just check D, and you can see that D is the not correct. 4214, way too big. Okay, so again, that's how you could use the strategy of picking numbers to solve this. Next up, question number 6. So this one, I will show you the traditional way how to solve this, but I think it is much, much easier just to use in Desmos. So I'm actually going to show the Desmos method first, and then I'll show the traditional way after that. So a lot of people got tripped up on this because when they solved it in Desmos, basically they either just typed the whole equation Okay, so they got two answers here, 0.462 or negative 0.923. And it says, what is the value of x is positive? Okay, so then they went and they said 13 times 0.462 plus 3. Okay, notice it's 9.006. So technically, that is what you would enter in if they did not give you any instructions about rounding, because that fills 5 decimal places right there. The 9 decimal point 006. But that's not the right answer, and it's not the right answer because this is a rounded value. This is not an exact value. So here is how you have to solve it. Here is how you have to do this to get the exact value. You have to solve this equation using regression, because regression will give you the exact value and you can carry it over and plug it into the 13x plus 3 to get the exact answer, which is actually going to be 9, basically just 9.00000. So all I do is I change the x's to x1s, I change the equal sign to a tilde. Now, here is my exact value. Even though it only shows like 6 places after the decimal, it has the others stored in there. You just don't see them. So now what I would do is I would type 13, not 13x, but 13x1 plus 3. We get 9. That's the correct answer. That's how you can do this question in Desmos in, under 30 seconds. But you have to use regression to solve it. Now, one thing just to be aware of. Technically, there are two answers here. Remember, there was a positive and a negative. So, for some reason, like if it gave you the negative answer, so for example, I'm just going to put this here, and let me see. No, it still defaults to the positive. But what I was going to say is, if you need to force Desmos to give you one of the different answers, what you can do is you can put little qualifier here in a bracket, like, x1 greater than 0. That doesn't change anything because we already had this. But if you wanted the negative one, you could make it less than 0. There's the other answer, and it's the exact value. Okay? So just so you know, that's how you can force it. And you don't have to use 0. You can use you can use another value, any value you want, just to like separate it on either side of what you're looking for. Okay, now I'll show you real quick. This is like the by hand method, the way that, you would probably see the explanation written out if this was in the question bank. Essentially, what they would have you do is they would have you move the 78x over, and then you're going to complete the square. Because if you notice, 169 is the square of 13. So it's like they're trying to get you to make 13x plus 3 quantity squared. So notice the square of 3 is 9. So basically you would add 9 to both sides, and then that would give you 13x plus 3, 13x plus 3. Right side you get 81. So we get 13x plus 3 quantity squared. And now you can square root both sides, and 13x plus 3 is equal to plus or minus 9, but if they tell you that the x is positive, well, then obviously it has to be the positive 9 for your answer. Okay, so correct answer is 9. This is how you do it up by hand, but I think it's much quicker, much easier just to do this in Desmos. All right, next up, we have another problem that you can either do by hand or again can be done in Desmos. First, I'll show the by hand method, and then after that, I will show you how we can do it in Desmos. So another quadratic equation here, it's talking about no real solutions. So this is kind of the opposite of the very first problem. We want to know what's the minimum value of b. So again, the traditional way to solve this would be set up your discriminant. For no real solutions, you want it to be less than 0. So b is just b, a is -1, the c is -900. This becomes b squared minus 3600 is less than 0. B squared is less than 3600. And now again, this is like I talked about in the first one, technically this is a quadratic inequality. So yeah, you square root it and you get 60, as your critical point, positive 60, excuse me, and negative 60. So now you have to see, like, basically you have to pick numbers and plug them in here and see do they match the original statement. So notice if you pick 0, which is in the middle here, if you plug it in, 0 squared is 0. Is 0 less than 3600? Yes, it checks. If you pick any number larger out here, like 100 and square it, and you get 10,000, or negative 100 and you square it and you get, 10,000 again, they're not going to work. They're not going to be less than 3600. So again, the only region where the solutions work or they lie is here between negative 60 and positive 60. So what's the minimum value of B? So here's where you have to be very, very careful. It's not negative 60. It's technically, for this problem, at least the way that I worded it, because I said B is an integer, the correct answer is negative 59. Now, we can go to Desmos and we can confirm that, because what's going to happen is if it's negative 60, then it is going to have exactly one real solution. Now, so we zoom out here. You can see, all right, yeah, there we go. Finally found it way down here. Okay, so you can see, like, if you want to make the values larger, right? Okay, notice that's not going to do anything. Like, it wants to know what's the minimum value. So, okay, right here, okay, right up here at 60, right? That's where it touches, but we want to know what the smallest value is. So we got to go the other direction. And essentially what's going to happen is when you cross 0, it's going to start going up on the other side. There we go. Okay. So notice negative 60, it's touching the x-axis. There is one real solution. So this is not the answer because we're told this equation has no real solutions. So what's the smallest integer value of b for no real solutions? Just past it. It's right here, negative 59. So the correct answer to this problem is negative 59, at least the way that I have worded it by specifying b as an integer value. Next up, question number 8. Here we have one that deals with basically relating x-intercepts and factors of a function. So you're given 3 points. These are all x-intercepts because they have a y-coordinate of 0. They want to know which of these must be a factor of the function. So the way that these are related is if you have an x-intercept value, the factor is just x minus that value. So the c here represents either negative 3 or 1 or 5. So these three x-intercepts would correspond to factors of x minus negative 3, which I'm just going to simplify to x plus 3, x minus 1, and x minus 5. So which of these do we see over here? X plus 1? Nope. X plus 5? Nope. X minus 1? Yup. X minus 3? Nope. So correct answer for this problem is just letter C. Now, question number 9 is a repeat question that we have seen before. These are technically different, slightly different numbers, but this has appeared, in previous tests and appeared on previous videos, but I'm still going to go through it because, people reported seeing it on the December test as well. So we have a rectangular region. It's divided into 76 little squares. I'm not going to draw all 76 squares, obviously, but each square has an area of capital R. So each of these, whatever is capital R. We also know that the length is 4.75 times the width, and importantly, the width is x root r. So this side of the rectangle would be x square root capital R, And then the length up here would be just 4.75 x square root r. So what we're going to do is set up an equation for the area of the rectangle. We know area is just equal to length times width, so that's just going to be 4.75 x root r times x root r. And then that is going to be equal to 76 times r, because the total rectangle has 76 squares. Each square has an area of capital R, so we can just set this equal to 76r. Now on the left side, as you multiply it out, you get 4.75 x squared r, and on the right side, you get 76r. You can divide these r's and cancel them out because they are not equal to 0. And then you can just solve this equation. So if you divide by 4.75, you should get 16 on both sides, and then you can square root. Technically, you get plus or minus 4. Obviously, we're dealing with distances, so the negative 4 doesn't matter. So the value of x will be positive 4. And now just to show you also one thing, if you want to solve this equation in Desmos, just a little practice, you could type 4.75 x squared equals 76, and then you can see you have vertical lines at negative 4 and positive 4. So that's one way to do it. You could also technically use regression, but if you do that, you have to change it to x1 or some other letter. And you can see here it gives us just the positive answer of 4. So that's just how you could solve the equation once you cancel out the r's in Desmos instead of actually doing it out by hand. All right, now the last question here, this is also another repeat question. This deals with basically the properties of similar triangles. I'm going to show you two different methods to do it. The first one involves similar triangles, which I just mentioned, but the second way basically involves trigonometry and does not involve any similar triangle properties. So what we have going on here is a right triangle. Okay, B is the right angle, A is up here, C is here, hypotenuse AC is 29, AB is 14 less than AC, so 29 minus 14 is 15. This side right here is 15. Okay, now, basically you draw this, where they talk here about drawing a perpendicular line segment from point B to AC. That's just an altitude. Basically, you're drawing an altitude to the hypotenuse like this. Okay, and now we have point D right here. So what happens in this situation is it makes three similar triangles. The large one overall, ABC, and then the two small ones, ADB and BDC. They're all similar to each other, meaning they all have the same angle measures and their sides will be in the same proportion. So what happens is, and I'm going to just draw these out separate because it'll be easier to visualize. Okay, you have ABC here, you got a 29 and you got a 15. Now, if we only look at this triangle down here, okay, BDC, if I orient it the same way, okay, D has to correspond down here because it is the right angle. And then what's going to happen is C is going to match up here, and B is actually going to go up the top and correspond to A in the large one. If you're not sure why that happens or how I got this, let me just show you a real quick example with like putting in some fake angle measures just to confirm that. Okay, these are not the actual angle measurements. We'll actually do that in the second method to solve this. But let's just say this is 50, okay, which would make this 40, right? So 40 plus 50 is 90, 90 plus 90, 180. Okay, then in the small triangles, this would have to be 40 and this would have to be 50. Okay, because again, we have right angles, we have right triangles, so on and so forth. So now when you line them up, right, this one has to be 40 and this has to be 50. Again, these are not the actual angle measurements. I'm just using these easy numbers, to work with. And so then notice in the small triangle, the one that I highlighted yellow, BDC, like C is 40 degrees. So that has to correspond to the 40-degree angle in the large one. So C has to correspond with C. B is 50 down here, this angle, that has to correspond to angle A in the large one. That's how I know B goes at the top and C goes at the bottom. Okay? So now that I have these lined up, it should be easy to see that the ratio of BC hypotenuse to BD leg is just going to be equal to the same ratio as AC hypotenuse to AB leg. Sorry, it's AC on, excuse me, it should be AC on top here. AC corresponds to BC. I wrote the wrong thing. There we go. Okay, so the correct answer to this problem is just 29 over 15, so you can fill that in, or you could also fill it in as 1.933 if you want to put the decimal equivalent. And that's it, because whether you round or truncate, it's going to be the same number. So this is how you can solve this problem using the properties of similar triangles. So this is basically what I would call method 1. Now, here is a second method which uses basic trig, does not use any similar triangle properties. All right, so let me just scroll down here, redraw the diagram. 29, 15, right here. Okay. We want to know the values of BD and BC. Okay, so we're going to figure out each of those values and then just put them into a ratio. So I'm going to first find BC by using Pythagorean theorem. 15 squared plus BC squared equals 29 squared. You know, I can get this leg of the triangle down here. And so technically, if you were writing this out, BC squared is going to equal 16. If you take 29 squared and then subtract 15 squared, and then you could square root it. That's 29 squared minus 15 squared. Yeah, 616. Now you could take the square root of that. Okay, and you get this value. Now, I am going to just show you actually, though, a much quicker, easier way to solve an equation using Pythagorean theorem, which will allow me to also define the exact value that I'm going to use later for the ratio. So what I'm going to do is I'm just going to type out the original equation, which is the BC 15 squared plus, and I'm just going to call this B squared. And I'm going to use regression. Okay, and solve it just like this. Okay, so now I have the exact value for B, which is really what I'm calling BC. So BC is approximately 24.8, blah, 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 whatever. But I have the exact value in Desmos. That's what I'm, going to use it to get my answer. Now, what we have to do is find BD. So the way I'm going to do that is I'm just going to use some basic trig. So I'm going to first find the measure of this angle A up here by looking at the overall large triangle and noting that the cosine of A is equal to the adjacent over the hypotenuse. So angle A is equal to the inverse cosine of 15 over 29. Okay, so now I just go to Desmos. I'm going to define that as A. Now, this does not look like a degrees, so I will just need to make sure that I'm in degree mode. Click the wrench up here, click on degrees. Okay, so now I have my measure for angle A. So next, what I'm going to do is I'm going to notice if I look at the small triangle here, so we can just orient it like this. Here's D, here's B, here's A. Okay, we know this side is 15, it's the hypotenuse, and we know that angle A up here is 58 point, whatever. So now if I want to find BD, I can think, okay, what trig ratio can I use? Well, BD is opposite, so I'm just going to use sine. So the sine of A is equal to the opposite, which is BD, over 15. Or in other words, BD is going to be equal to 15 times the sine of A. So now I'm just going to go back to Desmos. scroll down here, see if I can, there we go. So, and I'm just going to define this as D. Just 15 times the sine of A. And again, because I have A defined, here as an exact value, it will just carry it down. I don't need to retype 15.8526, blah, blah, blah. All right, so now we do that. Now we have the length of BD, 12.837. Okay. 37. So now we can find the ratio of BC to BD. So BC to BD, okay, is 24.8 blah 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 over 12.837 blah 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 blah. Okay, except I'm going to do them in Desmos, of course, because I want the exact values. I don't just want estimates. So remember up here, I defined B as BC, which is the top of my ratio, the 24.83. So I'm just going to do B over then D, which is technically representing BD. So there is your answer, 1.933, same exact answer we got using method 1. And now I can flip it and turn it into the fraction, not flip it, but turn it into its fraction form, 29 over 15 if you want to enter it that way. So this is how you could solve this problem entirely using, just basic trig properties, sine, SOHCAHTOA, sine, cosine, tangent, Pythagorean theorem. Using all those, you don't have to use similar triangles. You don't really even need to know anything about similar triangles to use this method. All right, so I hope you enjoyed this video. Basically part 1 of December 2024 digital SAT math questions. You have any questions or comments or alternate solution methods, please do leave them below in the comments section. Otherwise, check out part 2 once it is posted, and part 3 as well. And go back, and look in my playlist, and you can find, like I said, problems from the previous months: November, October, August, June. Yeah, back to, I think, May was the first month that I did some problems that were self-reported on the test. So be sure to check out those as well.